right. Hello, everyone, and welcome to today's National Geographic Pristine Seas live event. My name is Joe Grabowski, and I will be your host for today. In today's event, we're going to head live into the field to Niue to connect with the National Geographic's Pristine Seas team as they team up with the Government of Niue, Tofia Niue, and Niue ocean-wide. So Niue is one of the largest elevated coral atolls in the world and is located in the middle of the South Pacific Ocean. It represents Pristine Seas' third destination in the global expedition and represents a unique opportunity to build upon research conducted during the team's first expedition to Niue in 2016. In 2020, Niue created the Niue Moana Mahu Marine Protected Area, one of the largest marine reserves in the world at over 127,000 kilometers squared. So let's head to the Argo vessel now, where the team is conducting new research, including deep sea surveys of important seamounts and ridges using tools such as a submersible and drop cameras to observe ocean life at the depths. So I'm going to start by introducing Mr. Alan Friedlander, lead scientist for the expedition. Let's bring him in live. Hey, Alan, how are you?
Hi, Joe. How are you? How's everybody out there today?
Good, good. We have the Niue School hanging out with us, so I think we should bring them in for a big shout out. How are we doing, Niue School?
Good, thanks.
Good, all right. There we go. Well, good to see you. I'm going to put you backstage for a little bit because Alan is going to take us around the ship, introduce the crew, and take us into all of the amazing science that's happening on board. So, Alan, I'm going to let you take over for a little bit, and let's explore the Argo.
Great. Okay. Well, hi, everybody. And for the Niuean students, Whakalofa Lahiatu. Great to see everybody and excited to be part of this global expedition. As Joe mentioned, we are embarking on a 5-year expedition around the world, focusing on the Pacific for the next couple of years. And this is the third leg of the expedition. The first one was in the islands of Kiribati near French Polynesia. The second leg just finished up in the Cook Islands. We're now here in Rarotonga. We are about to set sail for Niue. It's going to be about 56 hours by boat to head out to Niue to explore some of the seamounts. But we've been doing this for almost 15 years, and this Pristine Seas team has been exploring remote, pristine places around the world. We've created 26 large marine protected areas equaling over 6.5 million square kilometers of some of the last wild places in the ocean. Now we're embarked on this amazing adventure with this amazing ship, the Argo here, where we're going to utilize all the assets that Joe was talking about. We have deep sea cameras, we've got submarines, we've got all these different high-tech tools, and we've got our Niuean colleagues who we want to, work with and help support their efforts to conserve their marine environment. Since our first expedition in 2016, Niue has become a global leader in marine conservation, protecting 40% of their waters for their protection of not only the marine life, but for their culture, their way of life, and all their resources. So now I'd like to introduce you to our Niuean colleagues. First, Noah, the head of fisheries. Come on, Noah. And tell us about yourself and what's going on.
Hey, good to see you again.
Likewise. It's been a pleasure as usual.
Yes, thank you. My name is Noah from Niue, with the fisheries team. Really looking forward to this trip. Very excited about it. It's been some planning along the way. It's finally good to see it happening. Very excited to watch the Pristine Seas vessel. Yeah,
all right, let's get going then, guys. Come on, Darren.
Hello from the head to everyone. My name is Darren Mahu. I'm the fisheries department for Niue, and a very good experience to be on board this Argo and with the Pristine Seas team.
Cool. Thanks, Darren. And Nam.
Hey everybody, Helen.
Good to see you again.
Hello to everybody, Janam Papatua here, together with the amazing Helen and also the Pristine Seas Argo. It's going to be super epic. We're here with, I'm here on behalf of Niue Ocean-wide to help out with the research as well as sustainable management. And we're going to head on board very shortly and have a look at some super epic stuff here up on the Argo.
Okay, everybody, let's head on the boat. We're going to take the first stop, check out the submarine. Let's go, guys. Small. That's gonna be it. Okay, everybody. So we're here aboard the Argo. This is the main deck, and this is our baby. This is the deep sea submarine. You can see glass sphere there. One pilot, which is Schmolik, and I'll talk to you in a second about the capabilities. And then we have 2 observers on board the sub. This can go down to 400 meters, so about 1,200 feet or so. And it's an amazing tool that we can use. We can film. We have a manipulator arm. We can get samples down in the deep depths, and it just opens up a whole bunch of opportunities that you can't explore any other way. So, Mr. Schmolik, and I'll let him take it from here. He's the creator, sub-pilot, knows everything about this.
Hey, excellent. So Alan almost said everything about it. The submarine can take 2 passengers and a pilot down to 1,500 feet. It looks pretty small from what you see here, but if you look here, this transparent bubble, this is an acrylic material, and it has almost, you can imagine it has the same transparency density of the water. So once the submarine goes under the surface, we don't see that. You really need to put your hands on it to make sure that it's there. And that's the magic of going in it. We are going in the fishbowl down and watching the fishes out, right? So that's what we do with the. We're going to take the scientists with us, and they will have all kind of requests, filming, collecting with the robotic arm. We will have here a collecting basket so we can bring samples with us from the deep water. The sub is very precise. It moves very precisely underwater, so we can approach small little things, and then we can have a good look and understand what we're seeing. And right now we don't have it here, but there's the camera that comes here, and we can record everything. So later on, we can sit up in our studio, so down there. And yeah, I mean, this is really a machine that takes us into inner space. So we're going deep into the inner space of the ocean. Cool.
So, what do you guys think about this?
Oh, it's super epic, man. Look at that. That's state of the art. It's like the stuff you see in the movies, guys. You see when you go down with the big machine beyond here, the robotic arm, you put a bit of bait in the front. Shots and whatever fish come to you. It's super epic. Super cool.
Yeah. So we're super excited to share all of this, y'all, as the expedition goes on. You can follow us, and I think that's great. We got a lot of stuff to cover, so we're going to move on to talk to Molly now. Molly is looking at environmental DNA, and she'll explain what more that is in a minute. So let's head towards the bow of the ship a little bit more. And
Hi guys.
this is Molly.
Hello.
Take it away.
So I'm going to talk to you about environmental DNA, and this is something that is kind of crazy because there's DNA everywhere, and by DNA it's like a fingerprint or like a barcode, so we know what different organisms and animals are, and you can actually detect this in the water. And so what we do is we collect it. We have these bags that are completely sterile. We go underwater, we open them up, we put a bunch of water in them that looks like this, we bring it to the surface, and of course we always have to wear gloves because I don't want my DNA to get into the sample. Do you know if I mean, it is everywhere. And in the water, it's from fish poop, from mucus. We have this incredible pump, and when we press the pump, water from our bags is getting in, and then it's flowing out, and it's being filtered in this little cartridge right here. And once all the water is filtered, we preserve this cartridge, and then we take it to a lab where we extract it, and then we get all these sequences of the different organisms. And what it does is it supplies another method to get a biodiversity estimate, to get organisms that we may not see during the dive survey. so we can have a more inclusive understanding of the ecosystem underwater. So I think we're moving on into the center of the cabin where you can see where we hang out and, you know, eat and sometimes play games like cribbage.
Okay, gang, on to the next spot. We're going to go into the salon here. So this is where all the important stuff happens. This is where we eat, and we have all our team meetings, and we've got this extensive library of marine science that we use for all our references. And this is Ryan Jenkinson. Ryan is the expedition leader. He's the person that makes sure we stay safe and everything's organized on a daily basis. And Ryan's going to give us a little quick tour.
Yeah, I think the main thing to tell you guys is you're going to hear about all of the work that we do out here on the ship. It's not super random. Everything is really choreographed and organized. So every night at the end of the workday, the whole team comes in here into the salon and we talk about what the plan is for the next day. Who's going diving, who's going in the submarine, what time everything's going to happen. And we have to map out every day before we even start. And all of it depends on the weather and what kind of conditions we have. So every day is something new and really variable, but this is our main meeting area. And if you look behind us, I can turn around, that's where we have all of our meals for the team. And so this is really where we spend most of our time when we're on board the Argo, is in this area, planning, talking, entering data after a day's work, eating our food. So this is the primary spot where if someone got on the ship, you'd find us at night or early in the morning. So enough of that. I think next we're going to head upstairs and look at some of more of the science work into the lab. So you can follow me up. All right, so this is the room that we have in the ship that's kind of our data center. It's where the media team has all of their gear, where we do a lot of the microscope work and some of the more fine scale science. So I'm going to turn it over to a few of our scientists here, Juan and Kike, and they're going to talk to you about the work that goes on here.
Hello everyone, my name is Juan, and one of the things that I do on the ship is maps. Some of you may not know or may not be familiar where Rarotonga is, and some of you maybe watching from YouTube don't know where Niue is. So this map here, I'm just gonna quickly show you. This is a map of the world, of course, and here in the South Pacific, I'm gonna slowly zoom in, and we're gonna go to the region where we're going to be working for the next month or so. So we are here right now in the Cook Islands, this area here, and we're headed towards Niue's exclusive economic zone. And believe it or not, we have better maps of the moon that we have of the seafloor. And this is the best map that we have for the, and the bright yellow points are these things called seamounts. These are these underwater mountains that we're going to explore all around Niue. Here, if we're zooming even more so, island of Niue, and in particular, we have very good map for that, for the seafloor of that region of the world. And this is very important because these maps allow us to do our work safer. You know, the submersible and the drop cams and everything else that we're throwing into the ocean. We want to know where is it that it's going to be at. So that's one of the things that we do here. And I'm going to pass it over now to Kike.
Hello guys. I am the benthic ecologist, and what does this mean? Benthic is everything related to the sea bottom, the sea floor, and I study from algae to invertebrates like sponges, like sea urchins, like sea stars, lobsters, and all kinds of animals that move or are fixed to the seafloor. Not fish. Fish is another thing. But all the other kind of animals, I study this. And well, and we can, usually what I do is I make transects. That is a line. I follow a line in the bottom of the sea, and I count everything that is in there. And if I have doubts in identification what it is, I collect them. And afterwards, I come here. I press in this amazing press here. If you can help me and put this up. And finally, I get this press with the different species of algae, in this case, and the name and the date I collected it. So now we can go to the microscope, for example, and let's see, you will see how this looks like in the, here, okay? And we can move that. And with this system, I can study the algae, I can take pictures of it, and and I can at the end identify every species to genus or even to species level, the finest level I can. Thank you.
Great. Thanks, Kiki and Juan. That was amazing. As you all can see, we've got a lot going on in this ship. Everything's packed in, but we're not done yet. So now we're off to the top deck, and we're going to talk to a couple of our friends who are working with different types of camera systems. So put that one out. Watch your cord, Steve. Watch your foot, Mom. Lots of tripping. Okay, so we've made it to the center part of the deck. Now we're on the top part of the ship. This is the open part. We've got, you can see our buoys, all kinds of different systems going on here. And first, I'd like to introduce you to Chris Thompson, our colleague here from Western Australia. And Chris has been working with these baited camera systems, and Chris is going to explain what these do and what he's doing with them. Take it away, Chris.
Thanks, Alan. Yeah, so basically what these are is we call them baited remote underwater video cameras, and they're just two GoPros in housings that face towards this bait canister. And so we deploy ones that sit down on the seabed, and then we also deploy some that sit out offshore in the blue water, and they allow us to count and measure anything that comes past. So things will be attracted into the bait. It could be fish, it could be other things. We sometimes see dolphins or whales. And they come in, check the bait out, and that allows us to record them on the camera, count how many there are, what type of species they are, and also because we have two cameras, it acts like your eyes and gives you stereo vision, so we can actually measure each of the fish as well. So we get a good idea about how big the fish are, where they are, and how many. So it's a simple system, but yeah, it gives us a lot of good information about what's in the waters.
And then what happens afterwards when you take the videos back home?
Yeah, so we process all that data, and we can then compare how many fish and how big they are and what species. We can compare that across the different locations that we've sampled. So we can look at, for example, how the communities in Niue compared to communities elsewhere, or we can also, because we sampled using these systems in 2016 when we surveyed in Niue, we can look at whether there's more fish or less fish than when we sampled before, or if those communities are changing in response to protection or other measures. So it's a really useful tool.
What's some of the interesting things that you saw when we were in Niue before using these cameras?
We saw quite a wide range of species. So we saw everything from things that you might expect, like we saw wahoo and tuna, but then we also saw some mako sharks, and we also saw probably the most interesting were plain-billed beaked whales, so really deep diving whales that you don't really see very often from the surface, but yeah, we managed to catch them on camera, so that was pretty amazing.
So that's really the benefit of having these camera systems is otherwise you probably wouldn't be able to see something like that.
That's it, yeah, exactly. And they're out offshore where it's not very interesting diving, you know, you're out in the blue, so things are usually distributed fairly patchily out there, so you have to spend a lot of time in the water to really find what's there, but these allow us to increase the amount of time that we're watching out there and just give us extra pairs of eyes to see what's going on.
Super cool. Thanks, Chris. Hope everybody's enjoying this. I am. I'm learning so much. And now, so this is our colleague Whitney Goodell, and take it away, Whitney.
Hello, everyone. I'm so excited to be meeting with you guys virtually. As you have seen from the rest of the team, we've got a lot of different methods that we use for science and to observe the waters around Niue. So one of the last things we have to show you guys is Chris talked about, you know, using cameras to see things that you wouldn't normally be able to see. So another area of the ocean that is really hard to actually see with our own eyes is the deep ocean, the bottom of the ocean. So we actually have tools to observe that, and these are our deep sea cameras. So these cameras, they can actually go down to the very bottom of the ocean. They can go down to 6,000 meters, which is most of the ocean except for the trenches. So these cameras can withstand a lot of pressure because down at the bottom it's massive, that pressure. So these cameras are amazing because they can go down without us. We send them down with bait. So the bait is going to attract lots of animals to the camera. The camera is actually right there. So it sits on the seafloor, and the bait is below it, and animals will come to it right in front of the camera, so that when the camera comes back up to the surface, we can then download all of that footage and see what lives down there. So we see really cool things like deep sea sharks that look nothing like the sharks that you see up at the surface. They look like dinosaurs. They look just old and weird, and they move super slow. There's all sorts of weird looking fish. Like everything down there is really alien. So this is our tool to capture all the alien life forms down at the bottom of the sea. And down there, it's really dark. There's no light that reaches down to the bottom. So it actually has really bright lights. These two arms are incredibly bright lights that light up everything in front of the camera. So this is, I think, the last of our tools that we're showing you today. All of these tools are intended to observe the ocean, observe what's down there or what's in the ocean, and really look at what you guys have in your own waters.
I've got a couple questions.
Yes, Alan.
So when you say you deploy them by themselves, how do they come back up again? And then have you ever lost one?
Yeah, so far, Pristine Seas has not lost one of these, so we're going to keep that trend going. But they're amazing feats of engineering. So actually, we program them, we load them with kind of pre-programmed missions, and basically we tell that there's a computer inside of this, and we tell the computer, you're going to stay down there for 10 hours. And at the end of 10 hours, you're going to release your anchor and come back up to the surface. And they come back up to the surface kind of passively. They're actually buoyant. So these are sort of like beach balls. So once they release the anchor, then they'll come right back up to the surface and send out a little signal that says, I'm here, come get me. And then we go pick it up and download all the footage.
And if that signal doesn't happen, is there other ways that you can recover the cameras?
There are backups. It's always good to have backup systems. So if we don't hear that signal, then there's actually a backup system that connects to a satellite network, and then the satellite network then gives us a notification on our phones or in our email that says, looks like you're looking for a camera, it's at the surface, and it'll tell us the GPS coordinates of where to go find it.
Cool. That's an amazing tool, Whitney. And you talked about all the neat things that you see down there, the bizarre sharks and weird animals. Remember, there's so much pressure down at depth, and there's no light, and there's a lot of things working against organisms to live down there. But when you find out like how best to survive, there's a sweet spot, and certain animals down there just thrive, but they don't look anything like animals you see in the shallow water, where there's not much pressure, there's lots of light, there's much more food availability. So it's a whole different ecosystem that Whitney's been able to explore and document virtually all over the world using this tool. And the beauty of this is it's fairly simple. She's got this thing, we can put a couple of them on a small boat, we can deploy them, they come back, and we can do it. So it really opens up a lot of opportunities. Oftentimes, when you're doing deep sea exploration, you're in large oceanographic vessels, it's very costly. But in this case, we've developed this amazing tool that's very cost effective to exploring the deep sea. So thanks, Whit.
Yeah.
That's great. And last but not least, our good colleague, Jess Cramp from the Cook Islands, she's home right now in Rarotonga, but we are taking her away and heading off to Niue. Jess and I have been working in Niue together for a number of years, and she's going to talk about that right now.
Kia ora, whakalofa lahi atu to everyone in Niue. My name is Jess, as Alan said, and I have what I believe to be the most fun job on the ship. I get to tag sharks. So the way that we do that is we actually will find them and we'll fish for them. So we use the knowledge of all the local fishers to help us out. Without them, I would be useless. I'm putting two types of tags on sharks. The first one is just for identification, and it looks like this. We call this a spaghetti tag because it looks like a piece of spaghetti. This one just has a tag number on it, and then we have, if a fisherman were to catch this shark, we ask the species, the tag number, the size, and the location. That way we might know where this shark swam to. Let's say we tag it in Niue and it swims to New Zealand. If a fisherman in New Zealand finds this shark, they can let us know that our shark swam at least that far. So this tag has no tracking information inside of it. It doesn't actually have any electronics. But we also put satellite tags on sharks. So they look like this. They're a bit bigger. So we usually put these on bigger sharks that are going to travel long distances. We've put over 30 of these tags out in Niue, primarily on silky sharks. They are most beautiful gray sharks. When we finish with the classroom, I want you all to Google silky shark so you can see what they look like. These tags are really, really cool. So they will swim along with the shark. The shark will tow it along, and they actually store data inside the tag. So they let us see where the sharks have traveled over long distances in the ocean, but they also show us the diving behavior, which is super cool. So we can see if the sharks, for example, they might spend most of their time between 200 meters on the surface, but they might take really big dives down to like 1,500 meters. And then at a pre-programmed time, which we usually use 6 to 12 months, there's a pin in here that will corrode. The tag will pop off, float to the surface, and then this antenna here will talk to satellites, which will then tell me that it's time to look at where our shark has gone. So these are really, really cool pieces of equipment. They're a little bit expensive, so we try to put them on the species that need the most help. So we're actually putting these on silky sharks, oceanic white-tip sharks, mako sharks. Those are the ones that are endangered by overfishing, and they'll help us find their critical habitats so we can then protect them.
I have some questions.
All right.
So first, when you catch the sharks, how do you get them to cooperate?
Well, it can be a little bit difficult at times, but we actually use ropes, which I can show you here. So we use ropes that help us secure the shark. We always keep the shark in the water, but we end up having to do a little bit of shark rodeo sometimes, which Dr. Allen's really familiar with. So we'll make a loop with the rope, and we'll actually put it around the tail. Yep, here we go.
No, you.
Here. Oh, you
can be the guinea pig.
Okay.
So Jess is the shark, and then we pull the rope there, and then what happens? How do you get the shark to behave?
Yeah, so the sharks go into a state of tonic immobility. It's a stress response, and think about it like going to sleep. So what we do is once the shark is secured in the water, we actually flip it upside down so it's belly up, and then we hold its pectoral fins down by its side, nice and tight, so they don't feel like we want them to know we mean business. Once they've chilled out, then we flip them back over, and then we start the tagging process. We always remove the hook, and then once we're ready, we have these really cool things called snap shackles, and when it's time to release the shark, we just pull on it, and they open up, and the shark swims away.
Okay, and a technical question.
Okay.
With those satellite tags here, how do they know where they are on the planet?
So these actually, they use geolocation by light. So it's pretty cool. They can collect the light levels here, and there are different light levels around the planet, and they can geolocate using light level information data. So it's not a true GPS, but it's some pretty interesting magic that you do behind it's all done.
Yeah, cool. So exciting stuff. And what kind of information have you found so far from the shark tags in Niue and the Cook Islands?
Yeah, so we have found, I can actually show you guys some tracks here. I've got some up. I don't know if you can see this on my screen. So this is just an example of, these are some oceanic white-tip sharks that we tagged here in Rarotonga in the Cook Islands. And you can see each different color is a different shark. And they went all over the place, which is really cool. But one of the things that these tags show us is actually how much time a shark spends in that particular area. So what we have found is that here in the Cook Islands, a lot of those oceanic white-tip sharks, they went over 1,200 kilometers to the north to an island called Penryn. And so that allows us to say, hey, we need to go do more research in Penryn to try to find out if there's more sharks there that we can protect.
Great. Thanks, Jess, and thanks, everybody. We've covered a lot, and I'm going to throw it back to you now, Joe. We've got everybody up here who you've seen so far over the Explorers Classroom, and we are all willing and able to take questions. So it's all yours.
All right. Well, Alan, wow. What a tour. What an amazing team. It's so great to see so many familiar faces. And you have such great gear that you'll be using over the next few weeks. Oh, you guys are going to have a ton of fun. All right. I'm going to bring in the Niue School. Here they come. And I want to see a show of hands here. How many in the school over there would like to join the expedition? Hands up high if you'd like to get on the ship and join the team. Anybody? Oh, there we go. Looks like pretty much everybody would like to join the team. That's so cool. All right. Well, this is your time now, boys and girls. You're going to take over for a little bit and ask your questions. The whole team is standing by. You can ask about the different equipment you saw, the boat, what they're going to be seeing. Any questions you have, now's the time. So who would like to start us off?
And from the Niue, remember the boat's going to be in Alofi Harbor. So we're hoping that you all can come and see the boat and do an actual tour in person.
All right, very cool. I think I saw someone with their hands up front. Do you want to start with the first question? Yeah, go for it.
What's the main purpose of the submarine in your expedition in that?
All right, can you just one more time, maybe a little bit louder for us?
What's the main purpose of the submarine in your expedition?
The main purpose of the sub.
Sub. So, I mean, when we're scuba diving, we can only go down to, 100 feet, 30 meters, something like that. With our deep camera systems that we talked about, they're remote. But being able to have people down observing animals, natural behavior, down at those deep depths, down at 400 meters, 1,500 feet, is a unique opportunity that most scientists, most people don't get to experience. And as Schmolik said, you're basically inside of a fishbowl. So think of you're in the fishbowl and the fish are outside. The opposite of what normally happens with a fishbowl. But that's the thing we're hoping to accomplish. There haven't been any deep water surveys around Niue using submersibles before, so this will be the first opportunity.
All right, so don't be shy. As you have a question, if you need to come up front, you can come right up close and go ahead. No need to raise your hand. If you have a question, come on up and let's hear those questions. And I should mention as well that there are people tuning in live via YouTube. So if you have any questions, you can use the chat sidebar and put those questions in, and we can work some of those questions in for the team. And I do see a hand there in the back. So if you want to come up and ask your question nice and loud.
Hi, I'm just asking if your research has got any data on sea level rise.
Okay. Does the research have any data on sea level rise?
Yeah.
the expert.
Possibly. Yeah. In terms of sea level rise, we don't actually have sufficient data in that area just to, but it's something they were definitely looking into. Looking alongside our counterparts, having office, there's also
All right. What do you think? Niue School, you got some more questions for us? I think I see someone standing up in the back. Yep. Here they come.
Before, just gonna, for the ones that go down in the submarines, do they undergo health checks before they go down?
Can you ask that a little bit louder?
The scientists who go in the submarines, do they undergo health checks on the boat before diving?
Okay. Are you wondering about kind of what they do to prepare, what kind of checks they do before going down the submersible?
Yeah.
Okay.
Yeah, what kind of checks they do for the submarine?
So, this sub's been around for I think about 10 years, maybe a little bit more. It's done several thousand dives. It's an incredibly safe submarine. And the interesting, cool thing about this sub, safety-wise, is it's positively buoyant, which means it wants to float to the surface. So if all the electronics and everything go bad, it will float to the surface on its own. So it's the energy, the batteries, the propellers, everything is used to try to keep the submarine down at all times. So it's physically working to stay down. So that's one of the safety features of the submarine. If all the power goes out, it will come to the surface. But yes, it's been tested, it's pressure tested. So the big sphere, the clamshell, comes together. That's all been pressure tested. And they go through, a series of safety checks every day before the first dive and then before the second dive, and then again in the afternoon. So it's a very well maintained sub. We've been using it for a long time, feel very comfortable using it, and we hope you all can check it out if you come on board the boat.
All right. Do you have another question there for us?
How long does the sub stay underwater?
How does it stay underwater?
How long?
Great question. How long does a sub stay underwater?
Sub stays underwater from anything from 2 to 4 hours, depending on how deep it goes. It takes a little while. It doesn't just drop to the bottom. It goes down very slowly, and then it explores on the bottom. So, 2 to 3 hours on average. Sometimes it's really interesting, and it's deeper. It'll stay down a little longer than that. You have to be careful not to drink too much, water or coffee before you go down, because there's obviously no bathroom on the submarine. But yeah, so that's the normal time.
All right. So I've got a question here for Jess and then one for Whitney. How many drop cam deployments is Whitney hoping to do over the expedition? And then Jess, how many shark tags are you hoping to successfully deploy?
So we have 3 camera systems for the deep sea cameras. We have 3 camera systems with us that every day that that we're able to, we're going to deploy all 3. And so it kind of depends on. Got a plane flying overhead. Sorry about the noise. It kind of depends on basically how many days we can deploy. Depends a lot on the weather. If we're able to go out and deploy them. So let's say we get 10 good deployable days in our time in Niue, then we'll get theoretically 30 deployments. So we're aiming for kind of around, maximizing the days that we have and getting all cameras out there.
Hi everyone. So as far as the sharks go, we do have a third type of tag, which I didn't show you because it's downstairs in the fridge, and that's called an acoustic tag. So we actually have 20 acoustic tags and we have 10 satellite tags. So that means, just like Whitney, we are trying to get 30 deployments done. But we have to be able to catch 30 of the species that we're looking for, which is where Noah, Janam, and Darren come in.
All right. Why don't we expand on that a little bit? What technique are you using to try and catch the sharks before you tag them?
What was that?
What techniques are you using to catch the sharks before you tag them?
Darren, do you want to talk about the long line?
Technique is where we use vertical long line. So we can sink it down in the bottom and flip them out of hook on the mainland. So to catch sharks in between different things. So we start from the bottom, then the bottom will be around 300 meters. So then we'll have a couple of hooks in the middle on the way up, so we can get sharks at different depths and more chance as well with the numbers of hooks. And another way we'll have just a hook on the line with floats at the end, just to get the sharks that are surfacing on the top.
All right, let's bring our students back in, see if there's any more questions from the classroom. All right, Alan, is Juan close by?
He is. Hold on one sec. Here he comes. Hello.
Oh, yes.
Juan, how are you?
Doing great, Joe. How are you?
Good to see you. So you talked a little bit about the maps and how there's so many gaps to fill in. Do you have any gear that you're going to be using to fill in some of those gaps on this expedition?
Unfortunately, we do not. The tools that you would use to do something like that are called multi-beam sonars. These are sonars that are attached to the bottom up to the hull of the ship. But these require a lot of work, dedicated person, and that's not a tool that we carry on board. So for this, we rely on the work that other institutions and other organizations and ships have done, which for Niue, it's very good. They did a very high resolution multi-beam map of the first 15 to 20 miles around Niue. But for the remaining of the areas around the Beveridge Reef and the other seamounts that we're going to explore, we don't have that quality of maps. As I briefly alluded to, we have better maps of the moon than we have of many of these places that we're trying to explore.
All right, awesome. Thanks, Juan. What do you think, students? You got a question or two out there for us before we sign off for today? Anything's fair game. If you're curious about the ship, some of the cool gear that you saw, the crew, how they got to be on the ship, anything you're curious about, becoming a marine biologist, any questions you might have. Oh, there we go.
How long does the expedition take?
Was that how long does the test of the ship take? The length of the expedition, Alan.
It's going to be a little bit more than 3 weeks. Like I said, we're leaving from Rarotonga in a few hours now, and it's 56 hours till we get to this place called Antioch Seamount. So we plan to spend some time there, and then it's several hours to Niue. We plan to be done at the end of the month on the 31st, so a little bit more than 3 weeks.
Have you found any weird creatures in Niue? In the sea?
Sorry, can we get that one more time?
Have you found any alien-looking creatures in our seas here in Niue?
All right, I think in the past expedition, are you asking about like new species, endangered species?
Well, I mean, last time we did see the big whale, And there's a sea snake that's endemic. It means it's found nowhere else. Sorry, another plane. There's a sea snake that's found only in Niue, and so that's always interesting. There's also a few species of fish that are found nowhere else on Earth. But like Whitney and Chris, and we've all been talking about, with all this exploration and all these new tools, we never know what we're going to find. Whitney's always finding new weird stuff on the bottom of the ocean with the drop cameras. So yeah, our hope is to document the endangered species. Humpback whales are in Niue right now. They're calving, and so that's exciting to be there when all the whales are around. And there's lots of sharks, and sharks are globally endangered. So having hotspots like Beverage Reef and other places, and having Jess work on understanding sharks much better is a unique opportunity, because not many places left have abundant shark populations.
All right. If Kike is close by, there is a question on YouTube that I believe is directed towards him.
Kike.
There he is. Hey, Kike, how are you? So we have a question here on YouTube. They would like to know, have you ever discovered and described any new species of algae?
The answer is yes. The answer is yes. And it was, sadly, it was an algae that we found in the Caribbean Sea that is specialized in killing corals. So it's a killer of coral. So, well, it's what it is. But, well, we named it Corallepida, that means that grows over the corals in Greek. So, and this was the name we put on it. But it's the only species of algae I have discovered so far and named it. Yeah.
All right. And how are you feeling about this expedition so far? You got good feelings?
Can you repeat, please?
I said, how are you feeling about this expedition so far? You have some good feelings about finding some good stuff?
You always have good feelings, to be in a boat like this with this bunch of people here that more than scientists are for me, are friends. So it's always a pleasure to come here. And for sure, when you get into the water, you always find new things and unknown things, at least for me, and at least for the region. And sometimes we could be able to find some new species for science.
All right, very cool. Let's head back to our students one more time. Last call. Is there any more questions out there? Maybe we can squeeze one or two more in before we sign off for today. What do you think, students? Any questions out there? I think, did I hear someone asking one? I need you to get closer if that was someone asking one.
Oh, yeah. Where exactly do you take the shark by its body?
Sorry, bud, can you try that one more time?
Where do you take the shark?
Where? Oh, good question. Jess, where are we tagging the sharks? When you get a shark, where's the tag going?
Okay, I'm going to turn that over to Janam because he's done that a bunch.
All right, cool. Hey guys, so with shark tagging, for the satellite tags are just behind the dorsal fin. So it goes right on the front there. And then that tag has to be well placed. You see punch in there, and there's another tag that goes right on the top. It goes with a hole puncher, you put the tag on the top there as well. So you have to make sure it's secure and nicely before the shark goes away. And that's how you do it.
All right, very cool. Well, it looks like we have the team nicely lined up for one final shot. I want to thank everyone who tuned in today. Those who tuned in via YouTube, those who will catch the recording later. Of course, we want to wish the whole team amazing luck during the expedition that's about to begin. If you want to check out more of National Geographic Pristine Seas, you can visit the website down here at the bottom, or if you search Pristine Seas in Google, it will bring it up there for you as well. I want to give a huge shout out to our students who joined us live today. Thank you for those great questions.
Thank you.
I hope when the ship comes your way, you're able to head down to the dock and to visit. That would be really cool. And then maybe before we sign off, I think there might be a small delay in the broadcast, but if you want to give maybe a big goodbye, a big thank you to the team to sign off and send them on their voyage. So if you want to get maybe a little bit loud and say a big goodbye and thank you to the Pristine Seas team and all the amazing local crew that are helping them out. What do you think, guys? Can you give them a big goodbye and thank you?
Thank you.
All right. Thanks so much, everyone. We are going to sign off for today.